All right, here are the answers from last night's homework. So starting off, the first one should have been 984. I know we did include the decimal yesterday, probably a better answer. But I did just do whole numbers for that side. So then I did 1014, 1033, and 997. Do you guys all agree with those? Who did them? On this side, I've got 29.86, 30.15, 30.56, and 29.26. Are there any of those 8 that we should double check? So first of all, I could have screwed up, or you might not understand. So anybody need help on any of these? Like, give me an example. Which one?
The last one.
This 29.26.
Yeah.
Let me see. So we got 991. What did you say? Oh, you did it wrong.
Yes.
So not that far. You could be like point on this side. So the ones where you were going to inches of mercury, your answers could probably be 0.01 off. So you definitely picked a completely different number when you were doing yours. So let's just go over it. It's good to go over one just to make sure. So we'll go over that one. 991. So 991, there's 992. 991 is this. I'm actually gonna go that way. So there's 992. 991 is one line underneath that. So 29.2, there's 29.25, 0.26, or 0.27. So what do you say? Yeah, you were up at 996 perhaps. So you just went to the wrong number. So same deal as yesterday. Like if you got 1 wrong, maybe 2 wrong, I'm sure you know what you're doing. You just made a mistake like Dakota did. When you only have one of these on a test question, hopefully you'll be taking your time and double checking to make sure you had the right number to start with. So as long as you got most of these right, I'd say you know what you're doing. So I do know in this class, we did get behind yesterday. Can you guys tell me, did we, on the front page of the packet, did we complete the temperature page?
Yeah.
Even the very bottom? That's what I thought. So that's actually where we need to start off with. And it's stuff you already know about. So we're at the bottom of the front page of the packet, and it says heating and cooling of air by expansion and compression. So just a quick review of stuff we learned at the beginning of this school year. Guys, what does warm air do? Oh, it does expand, okay. So where does it go as well? Warm air rises, and cool air sinks. And then you guys were able to tell me that warm air expands. So just in case you forgot. So remember, I always compared it to people. When you have hot, sweaty people, do they like to be in a bunched up group? No. Hot, yeah, no. I mean, and if you do, you're weird. I'm sorry, I'm judging. Hot, sweaty people need to spread out. So do hot, sweaty molecules. They don't want to be near each other. So they spread out or expand. Now, just like people, here's the part we never talked about before. Once those hot, sweaty people are spread out, what happens to their temperature? Yeah, you cool down. Now that you're spread out, you've got some airflow and you're able to cool back off. Molecules do the same thing. So when they're warm, they spread out, but once they're spread out, they cool down. Now, what do freezing cold people who have no other choice do if they have no blankets, no more clothes, no fire, no nothing? They huddle up together, or as I like to say, they cuddle. Cold people need to cuddle, so do cold molecules. Cold molecules end up, it's called compressing, so they squish together, or we can call it cuddling. So cold molecules cuddle, cold people cuddle. Once you're cuddling, what happens to your temperature? It goes up. Same thing with molecules. Once they're all compressed into one space, they're going to warm up. And that really drives most of our weather systems out there. The fact that warm, spread out, and then cool down, and that cold cuddle and then warm up literally controls most of the weather stuff that happens on Earth. If that didn't happen, weather wouldn't be the same. So that's what goes in the notes on the bottom of page 23. And it is a little bit of writing, and yes, I do want you to write it. So you already have the title. You need these 2 bullets with their sub bullets. So I'm just gonna stop talking and let you do those. So this comes back, does anybody, no, actually, I don't know if you would remember, maybe you do. This is convection. So when we talked about the lava lamp, yep, saw some of you guys talking about circles. With the lava lamp, remember that the warm lava, it got heated up, it expanded, which made its density less. That's why it went up, because it was spread out. Once it got up there though, it got cold. It got cold because the molecules were spread out, so then it sank. So it's the same thing we talked about at the beginning of the school year, just now in kind of different terms. All right, so that was the end of temperature. That's where we should have left off actually on Monday, I'm not gonna lie. And then yesterday we were supposed to do all of air pressure. I just pushed you right into how to convert yesterday. But air pressure isn't a difficult concept. So I think we'll be okay. So if I just asked you, what is pressure? Would you be able to tell me? Okay, so a few of you did some charades. How about this? If I asked you to put pressure on your desk, what would you do? Okay, so everybody knows what pressure is. You all just pushed down on your desk. So what do you think air pressure is? It's exactly what it is. So at the top of the page, air pressure is actually the weight of the Earth's atmosphere pushing down. It does change depending on temperature. I want you to think about that last bullet. Changes depending on temperature. I would like you to kind of think through that. How can the weight of the atmosphere change depending on the temperature? Think about what air does. Say again, what? Whether it's hot or cold. So what does it, let's talk about cold. Do we think that there's going to be more or less pressure pushing down on us if it's cold. Everybody think this one through. Sophia, you wanna try it? Less, why? What does cold air do? Mm-hmm. It's not quite it. I appreciate you trying though. You've got most of the concepts. You got starting with, they go together. Who else wants to try and explain this one? Be brave, like Sophia. It is more.
Okay.
So, McKenna, you wanna try it? I'm sorry. McKenna, you wanna try it? Not wave, what's the word we're looking for? If they compress, they're more dense. TJ can't handle it. Got an answer. TJ says they're more dense. So let's walk this through. Everybody think this through. Cold molecules, what do? They compress, they cuddle. And when they're cuddling, what's their density? More dense. And what do more dense things do? They don't weigh more, they sink. So when they're more dense, that's, you can't interchange the word dense and weight. So when they're more dense, things sink. Now think of sinking. What did your hand do when you're putting pressure on the desk? It kind of sunk. You were pushing down. It's kind of not the same as sinking, but when something's sinking, it's pushing down. So when cold air is sinking, it's pushing down on you. So when it's colder outside, there's more pushing down because the cold air is sinking and we have higher pressure. Now let's think about the high, when it's warm out. What's the air doing when it's warm out? It's rising. Now something is rising off of you. How's that weight feel on you? Lighter. So like if something's rising off of Riley's shoulder here, she's not feeling it push down on her as much. So cold air is going to push down, warm air is going to pull up. So you will feel more pressure with cold air, less pressure with warm air. And we use an instrument called a barometer to measure this. So that's the next bullet, by the way. A barometer is the instrument used to measure pressure. I'm not sure if I mentioned this yesterday, but we're going to learn 5 weather instruments this year. You already learned one yesterday, a thermometer. Your second one today, a barometer. There will be one question on the regions, or at least there has been every other test I've seen. Will be one question that makes you match up a weather instrument with what it measures. So you already have one memorized, the thermometer. Now here's the second one to measure. To memorize. A barometer measures pressure. Just like we talked about yesterday, it measures it in 2 different units, inches of mercury and millibars. There are other units of measure, like yesterday, I believe we talked about pounds per square inch. That's how much pressure is pushing on you for every square inch of your body. We don't use that one in science, so just need to know with the inches of mercury and the millibars. That was your homework, learning to go back and forth between the 2 of them. So we already know that. On a weather map, so just like there's isotherms, there's isobars. These are lines that connect areas of equal pressure. We learned this in chapter 2. And like I said yesterday, we will be doing a lot of weather map stuff with isobars and isotherms. So we'll review those before I throw them back at you. But hopefully you remember the gist of connect the dots for slightly older kids. Yay, everybody's favorite. Actually, I don't think you minded those as much as like earthquakes. Maybe I'm wrong. Now, everything we just talked about with how pressure works with temperature is going to go into the next set of bullets, which you'll notice is kind of long again. So it talks about a barometer. So here's the basic gist of a barometer. So a tool that measures pressure. This is an old school one, but the concept still works the same for newer ones as well. So we start with, in this case, it's basically a dish of mercury. Mercury is a metal. It is liquid at room temperature though. We don't use it anymore because it causes brain damage. So it was, you shouldn't have handled it. You shouldn't have ate it. You shouldn't have licked it. And you laugh, but that is actually what people did with mercury. Mercury was really, is really cool. It kind of globs together. And one thing that people used to do, because it was neat, is it would be in a puddle somewhere because you would dump it out and it would kind of be like a liquid, but it would hold together. And every person my mom's age always talks about this. One thing they used to do is slurp it up into their mouths because it was like a glob. And so that was how you would contain it. Every person my mom's age, if you ask them about mercury, they'd be like, oh yeah, that's what we did. Mercury causes people to go crazy. In fact, the Mad Hatter from Alice in Wonderland, it wasn't mad like angry mad. It was mad like, he was mad like crazy mad. And that's because the process of making hats apparently used mercury. I don't know why or what for. I've never made a hat. Don't know what you would need mercury for, but that's what happened. That's why he was mad, because he went crazy from mercury poisoning. Totally off topic though. So we got a dish of mercury. And in that dish, there is a closed test tube tipped upside down in it. So it's like just like a pipe almost. And what happens is those inches are marked off. So hence the inches of mercury. So it's just inches like a ruler. And when the air pushes down on the dish of mercury, well, where is it going to go? Up the tube. And then you can measure how many inches of mercury it's gone up. So that's a barometer. So when it was high pressure, it would push down on the dish and cause the tube, the inches to go up. When it was less pressure, meaning the air was rising, so instead of pushing down, there would be not any pressure on this and the mercury would go down. What do you need to put in those lines? These concepts of how a barometer works, and then the cold air and the warm air. After this, we have very little writing. So, well, we have wind, but it's not as much, I promise. Everybody got that, or should I leave it up for a little bit longer? All right, then one last thing at the bottom. And I kind of want you to think this one through first. We got to draw a graph. And that graph is going to be about the relationship between altitude and air pressure. So first of all, do you guys know what altitude means? Yeah. Okay, Zach just pointed out. Altitude means how high in the sky you are. So like they will say if you're in an airplane, the cruising altitude is, and they'll give you a couple miles or something. That's how high above the earth's surface that airplane is flying. So we want to talk about what happens to air pressure as altitude increases. So again, I'd like you to think this through. Think of the definition of air pressure. The weight of the Earth's atmosphere pushing down on you. The Earth is, but we're talking about the air. I'm not talking about Earth here. I want to know what the air is going to do as you go higher in the skies. Let's draw a picture. Maybe this will help. Here's you standing on Earth. How much atmosphere is on top of you when you're standing on the Earth? One atmosphere. What is the atmosphere, by the way?
Layer of gas surrounding.
It's the layer of gas that surrounds the Earth. So there is a whole bubble around the Earth. It's sometimes referred to like an envelope around the Earth. That's the atmosphere. So when you're standing on the Earth, how much atmosphere is on you? The whole thing, which, like you said, that's one atmosphere is on you. So now let's go up into an airplane. There's my airplane. You like that? Yeah. Okay, at least resembles an airplane, right? Okay, whatever. How much atmosphere is on that airplane? Is there a whole atmosphere on that airplane? Okay, there's not. Now, the only atmosphere on top of that airplane is that much. In my drawing, it looks like a third of the atmosphere is there. So in this case, there's only a third of the atmosphere still on top of you. So in this case, your air pressure is going to be 0.33. There's less air pressure the higher you go in the atmosphere because there's legit less atmosphere on top of you. The same is true, I guess the opposite, if you'd like to think of it this way. How about when you're underwater? What happens when you go to the bottom of the pool? The whole pool is on top of you, so you're going to feel pressure from the pool. So it's the same, just water. That would be water pressure. Are you good with that? You look confused. No, you're good. So air pressure, what happens as you go, what happens to air pressure as your altitude increases? Decreases. So we need, though, make sure you include the labels. So as altitude increases, pressure decreases. Yes, it is. All right, I'm going to try and catch us up to the rest of the classes. So this is officially what we should have been doing today. So sorry, this was a lot for you guys. You pretty much had yesterday off because I couldn't get my act together yesterday. All right, so we're going to talk about wind. Do you guys remember the word equilibrium? I think you talked about it a bunch last year.
Yeah.
Equilibrium. What's the general gist of equilibrium? Okay, what does this mean, TJ? I got nothing.
Like that, yeah. Two things are equal.
Hey, equilibrium is everything likes to be equal. One thing you talked about a lot last year was like osmosis and diffusion when through the cell, and I don't know all the gist of it, but the cells they want equal amounts of like water on the inside of the cell, on the outside of the cell. And what way does stuff always move from blank concentration to what concentration? Remember? Always goes from high to low. So the waste would go out of the cell because there was high concentration of waste in a cell, and the cell wanted to push it out so that it goes from high to low concentration. Well, wind is the same thing. The earth likes to be at equilibrium, and it's the wind's job to push the air around to make everybody equal. So wind is caused by that uneven heating. And it really comes back to equilibrium. If the earth is heated unequally, so different temperatures will cause different pressures. Remember, if it's cold, we have higher pressure because air is pushing down. If it's warm, we have lower pressure. Well, the earth doesn't like some places to have high pressure and some places to have low pressure. So just like the equilibrium with osmosis and diffusion, the wind will blow the air from high pressure to low pressure. So we've been having a bunch of windstorms recently. At least where I live. I'm assuming you guys have had them too. There was a pretty strong winds over the weekend. It's been fairly windy. Let's talk about this last two bullets. The greater the pressure difference, the stronger the wind. How do we know we've had huge pressure differences like this past weekend? DJ, you know what's going on?
Oh,
No. We have really big pressure differences this past weekend. How was the weather at the end of last week? Nice. How was the weather this past weekend? Not very nice. In fact, didn't it snow this weekend? And then what is it now? Nice. Notice those pressure or those temperature changes. So we started off with high temperatures. When we have a high temperature, remember we have low pressure because the air is rising. Then we went to cold temperatures. Cold air sinks. So we had a high pressure. So because of the temperature differences, we had different pressure differences. Then because the wind will always blow from the high pressure to the cold pressure, or to high pressure to the low pressure, it is going to be windy. The bigger the difference is, the stronger the wind. So we went from really nice to really yucky. That's why there was a big windstorm. On a weather map, now remember how we had those isobars and those iso lines? Remember when we were talking about elevation, when the lines were close together, we had a steeper hill. Here, we're going to have what's called a steeper gradient again, meaning a big difference in the wind. So you can tell where it's going to be windiest on a weather map by looking at the isobars. If the lines are close together, it's going to be windier than if they're far apart. All right, one more thing we're going to try and squeeze in here are well, actually two. So here's an ISO map. What section of this map do you think is the windiest? No, the blue is water.
oh,
This is the Great Lakes right there, the Atlantic Ocean. Mrs. Ritz? Yes. Okay, sounds good. Yep, bye. All right, so where is it windiest? Top left. Here's the top left. I believe you mean the northwest, but we'll go top left. This is one place it's windy. Why is it windiest here? Not because it's got higher pressure. Lines are closer together. Same with here would be windy or over here. Over here, it's not windy because the lines are farther apart. Yeah, we already did that. Sorry. Oh, one last bullet. That's what I wanted. One last bullet to go there in big, bold, capital letters. Wind is always named for the direction it comes from. So if we have a southerly breeze, it means it's coming from the south. Or a nor'easter means the storm is coming from the northeast. The reason we name it for where it comes from is that way we know what kind of weather to expect. If it's coming from the south, we can expect warmer. If it's coming from the west, we can expect drier, and we'll talk about why in a second. We're not done. We're going to keep going here. There are two wind instruments. We have an anemometer and a wind vane. You will often see these guys together. You'll often see this one with a rooster on top of it, on top of a barn. And they both work the same way, but they measure different things. Any idea which is which? Yep. That's exactly it. So please, you see these pictures off to the right? Underneath anemometer, please write wind speed. So the wind gets caught in those cups. Some sort of instrument measures how often those cups spin around, and you'll get miles per hour. The wind vane, you can see with the arrows and the north, south, east, and west, it'll tell you what direction the wind is coming from. All right, here's the last thing I want to try and squeeze in, and this will be kind of tight here. There are, ever been to a beach? How's the wind at a beach compared to your house? It's typically windier at a beach. Often why you see people flying kites at beaches, because it's windier there. Here's what we need, how we got to talk about how you know, or why it's windier at the beach. So we'll start off. Do you see the two pictures? One labeled sea breeze, one labeled land breeze. Besides the titles, do you notice anything different? How do you know one's a day and one's a night? Okay, so one has the sunshine. This one has the sunshine. Can you write next to the word sea breeze, write daytime? And down below where it says land breeze, please write down nighttime. Oh, you know what? We're going to actually stop here besides that. So you guys can, you have homework tonight. And your homework are the Regents questions on page 24, 26, and 28. I would like you to put effort into answering those questions. So if you're stuck, you can look back in your notes. You will get stuck on question 21. And for second period, I'll let you guys skip question 21 because we didn't do it yet. But my other classes will have page 21 done. So we'll stop there.